Hey everyone, Dr. Crayhay here. This week we're talking about variance. So how do our scores, how much do our scores vary from the mean? How do we tell that? How do we get a sense of that kind of thing? And so there are a couple of things to talk about here. We can talk about range, we'll talk about variance, we'll talk about standard deviation, and then we'll talk briefly about the empirical rules. So let's get started. The Khan Academy video that I linked to in our last lecture was hopefully a useful introduction for you. And then here, I'm going to break it down a little bit more. I'm going to make what I call a variance table. I'm not sure if this is the official name for it. Actually, I tried to do a search and I couldn't find it, but this is how I was taught, and this is what makes the most sense to me, and I think it will help you as well. So we'll go through that here. So what I have, I just have a document opened up in Microsoft Excel. So hopefully you are at least a little bit familiar with this program. If you don't have it installed on your computer, I would recommend pausing this video and getting that through IUware so you can get it for free. This will help us to go through these calculations step by step. So when we use SPSS, it's going to jump to the end result and we'll miss some of what's going on in between. So when we do it step by step, I think it gives us a better understanding. So you'll want to make sure that you have Excel. I would recommend following along if you're able, or trying to replicate this on your own. It is required that you make a couple of these in your homework, so you might as well work along with me so that you know what's going on. Okay, that being said, let me explain what I have going on here. So in the first row, so this is a row, just in case you don't know that, these are rows in Excel. These are columns, so we have a couple of different columns here. On our first row, I just have some titles here. So here, participant, we have x minus x bar, x minus x bar squared. So in this first column, I have listed some participant numbers 1 through 10. We're not really going to use that. It was just for my purposes. I wanted to make sure we had 10 people. And then we're going to calculate some stats down here in just a second. So those are here to help us. In our column B, we have X here, so this is just our raw data. So whatever person 1 scored on X, that's right here. So person 1 scored a 5, maybe it's on a quiz out of 10 points. Could be, I don't know, they were able to find 5 novel uses for a paperclip in under 30 seconds, something like that. Whatever your data happens to be, this is our variable here, X. This is the score for participant 1, participant 2, participant 3, so on and so forth. In column C, we're going to start to pick apart those formulas for variance, standard deviation, all of those things. And to do that, we need to take our raw score and subtract the mean. So that's what x bar is. So if we were drawing this out, it would be an x with a bar across of it, the top of it. I'm just going to call it x bar because it's hard to, it's hard to enter those kinds of symbols into Excel. So we've got x by minus x bar. We'll do that calculation here in just a second. And then we've got x minus x bar squared, and we'll do that calculation in just a second. You could do this in Excel. You could also do it by hand. I just, Excel's easier. You don't have to think about the math. You don't have to make those mistakes here. So we'll calculate those in just a second. First, let me show you what I've got going on in the lower left here. So we have our our Greek symbol here. So this is sigma, which stands for sum. So we're just going to add things up here. We have our n. So here I'm assuming that I've put lowercase n for sample, but it should be capital in some of the population slides that I'm about to talk about. Hopefully I'll remember to fix that. Then we have x bar, so we're going to calculate the mean right here. We're going to get the minimum, we're going to get the maximum. All of these things are going to come together. We'll just walk it right down the line, and eventually it's going to get us to the calculation of standard deviation. So let's start here. All across this line in these blue squares, I want the sum. So hopefully you know this. Hopefully you've done this before with the formula equals sum, open parentheses, and then select that data and hit enter. Now what I'm going to do to make my life easier, you'll notice right here kind of above my cursor in this lower right corner, there's a little green box. If I grab that and drag it over, It's going to also sum what I have in column C and column D in those same rows. So it changed the columns to C2 through C11, and then this one's D2 through D11. Sorry, you can't see that. But equals sum of our raw scores here. So that's what it's doing. If we want to get the count, so again, small n would be sample, big N like this would be population. We'll do small for right now. We will take equals count. So the count function will count how many numbers are in a specific area, and then I select the data, and this should be 10. There we go, so 10. So our scores sum to 60. We have 10 total scores here. So to get our mean, hopefully you know that. So what's the formula for a mean? Well, you take the sum of your scores and then divide it by n. So we have that, and we have this. So we can just do equals the sum of our scores divided by the number of scores that we have. Hit enter. Our mean is 6. Okay, so now we need the minimum score. Again, we can do this really easily. Equals min, open parentheses, select the data, and hit enter. We're going to go to maximum equals max, open parentheses, select the data. So we'll use min and max to calculate our range. So we can go ahead and do that right now. Our minimum score is 2, maximum score is 9. So over here I've told you the range. So we want to know what is the range of this data. Take the largest number, subtract the smallest number, and you get the range. So what I'm going to do is a cell reference. So I'm going to hit equals. Now I'm actually going to click on this cell over here, B17. So I'm going to click on it. Minus, I'm going to click on B16. So it's entering the formula. Whatever is in those two cells, it will, change, and it will calculate our range. So let's hit enter. Our range is 7 in this data. So we're just taking the highest number from these 10 people and then subtracting it from the lowest number for these 10 people, and our range is 7. Okay, so now, the range might be kind of useful occasionally, but you're not going to see it very often. It only uses 2 scores. Very limited data goes into calculating it, so it's not horribly useful. What we need to look at, ultimately, standard deviation is going to be the most common, but we can do the population variance. But to do that, we need to get to sum of squares. To get to sum of squares, we need to ask ourselves, how far do these scores differ from the mean? So here I've clicked in cell C2. We want to know how many away from the mean is 5. So we know that our mean is 6, so we're just going to take 5 minus 6, and we'll get -1. So there's one deviation here, one unit of whatever it happens to be. If it's a quiz point, if it's a mile that we ran, if it's, whatever it happens to be, there's one deviation from the mean here. We're going to do that for all 10 scores, so let's use Excel to make our life easier. So again, I'm going to start with equals. Every single time we're going to need our raw score. So I'm going to click in B2 to get that raw score. Now we're going to go minus X bar, and I'm just going to click down here in B15 where that X bar is. Now we can hit enter, and we will know that one deviation. So this raw score is 1 below our mean. Now, one thing, if you're in your comment bar above, let me paste this down so that you can see it. Let's see if I can do that. Okay, I will, hang on just a second. I will type what I'm seeing in my comment bar. You'll see equals B2 minus our mean is in B15. B15. Okay, so this is what my formula bar is showing. Again, I apologize for not expanding the recording screen here. It's going to say B2 minus B15. Now, I'm a big fan of dragging and dropping our formulas here. So what it will do when you pull it down is it will change the B2 to B3. It will change B15 to B16. So we want part of that to happen, but we don't want the mean to change, right? We want the raw score to change, but not the mean. So what you need to do here is right in front of this, B15, where we're identifying the mean, put a $sign before the B, so that will hold the column the same, so it won't change. And then again before the 15, it will hold the row the same. So if you do that, change your formula bar to that. Let me do that over here in mine. So all I'm doing is changing my formula to match what I've put here and hit enter. Now we can drag this down and we see here it changed to B3, B4, B5, B6, so it's taking the raw score, but it's holding this mean steady, so it's subtracting that. So hopefully that made sense. So now we have a column of our raw scores minus the mean, and we sum that up and we can see every single time you do this, this number should sum to 0. Remember what the mean is, right? It is the mathematical balance point. Exactly 50% of the scores are below, 50% are above. So when you subtract everything from the mean and then add up those deviations, you should always get 0. That is why we square them, because 0 is not a particularly useful number, so we square them so that we can then later easily unsquare them, take the standard deviation. So that's our next step. So if you have 0 here in your sum of deviations, you are on the right path. But the next thing we need to do is square that. Now, you could do this. You've probably seen this done, and in the video, Sal Khan did it all in one step, but I like to break it down. So all we have to do here is in D2 equals, we're going to square that deviation, right? So we're going to take that deviation of 1, we're going to multiply by itself. So C2 times C2, hit enter. Our squared deviation is 1. I'm going to drag this down so that it gets to all of them. So here we have squared deviations from the mean. So this raw score of 5 is 1 squared deviation away. 6 is the mean, so it's 0 squared deviations away. We've got 4, 1, 4, 9, 16. Down at the bottom here, we are summing up those squared deviations. So this number right here, this 52, we call the sum of squares because it's the summed square deviations from the mean, remember? So we take this, how much does it deviate from the mean, but that adds up to 0, so let's square it and then add it together, sum of squares. With the sum of squares, we can do some really cool stuff. So let's look at population variance. So again, we still got our sum of squares here. So we have this fancy formula for population variance. So here we have our little symbols here, sum of mean, raw score minus the mean squared. So you've already done that numerator, right? Right? This numerator should look very familiar to you. That's what we just did. It's the sum of squares over n. So we've got fancy looking formula, or a more useful formula for us, the sum of squares over n. Well, look, you calculated the sum of squares right here, so it should be really easy to find our population variance. Equals our sum of squares divided by the number of people in our sample. So the population variance should be 5.2. Now, what about population standard deviation? So again, we have our population variance here up top still. We go down a step. So these should look very similar to you, right? So here you have the sum of x minus the mean, so the raw score minus the mean, you square that, divide by n is your variance. Look here, the sum of your raw score minus your mean squared over n. So this is just your variance. So the population standard deviation is taking the square root of your variance. So that's what I've got right here, the square root of the population variance. Pretty straightforward at this point, right? So just do equals SQRT, open parentheses. Our population variance we calculated in the last slide, 5.2, hit enter. Our population variance is 2.28. So again, we're just taking this into small pieces. You could calculate it using this formula. You could do it the way that the Khan Academy video did it, but this will help you to check step by step where you've gone wrong or what you're doing right. So let's look at sample variance. So again, population versus a sample. Very rarely in the social sciences will you have a population, right? So that would be every single person that you're interested in. Very rarely do we have the money, the time, the resources to collect all of that data, so we'll have a sample. So there are some corrections that we need to do there. Most of this is still going to be the same. So here we have our population variance formula, just like we've been looking at. It is the sum of the raw score minus the mean, square that, and then take that over n. Sum of squares over n. We calculated that to be 5.2. Looking at the sample variance, you'll see it's basically exactly the same, right? So we still have the sum of your raw score minus the mean, square that. This time you're going to subtract a 1 from your number of people, from your sample number. So we have a different symbol for our mean, but overall it's basically the same thing, right? So we say simplified version, sum of squares over n minus 1. Calculate that, equals, we have our sum of squares over here, still 52, so I'm going to click into D13. So I've clicked there. In my denominator, I need n minus 1, so I'm going to do divided by, open parentheses. My n in cell B14 is 10, minus 1, close parentheses, hit enter. My sample variance is 5.77. We would round that to 5.78, but let's not round right now, because we want to take this one step further, and I always try to round at the last possible moment. So let's see, sample variance, very similar to population variance, and our sample standard deviation again is going to be very similar to the population standard deviation. So here we have sample variance, the sum of our raw score minus the mean squared over n minus 1. Look, right there, sample variance. That is your variance formula again. So you're taking the square root of your sample variance. Same thing here. So all we had to do, calculate those sum of squares, and we can just input those in to our variance, calculate that way, and then plug that in, get the square root. So over here, my box, I'll go underneath the equals because I didn't extend it out enough, equals square root of our sample variance, which is in Q6, Q5, hit enter. Our sample standard deviation should be 2.4037, so we would round that to 2.40. So hopefully this has helped to illustrate how all of this kind of builds on each other. So going way back to the beginning, we took our raw scores, subtracted the mean from the raw scores, but because that sums to 0 every single time, we have to square those deviations, and then we sum those squared deviations. This number, this sum of the squared deviations, we just call it sum of squares, and then we can take those sum of squares and divide it by n for the population variance, divide by n minus 1 for sample variance, and then using the variance, we just take the square root of that. So take the square root of population variance, and you get the population standard deviation. If you have the sample variance, take the square root of that, and you get the sample standard deviation. And you've done this in a couple of broken down steps to minimize errors along the way. Now, if you have any questions about that, please send me an email. I can go through a couple more of these if you would like, or just play around with it on your own and see how it goes. You can also check your work. So like I said, with SPSS, it's going to jump to the end of the calculations. So let me pull SPSS up here. Hang on just a second, I have to get it fit into this kind of weird recording area that I've made for myself. So what I've done here is I've created a variable called x, and I've input the same data. So you can see right here, first score was 5, 5, second was 6, here's the 6 again, 8, 7. So I just input this data from Excel into SPSS so that we could check our work. Analyze, descriptive statistics, frequencies, move your variable over, hit statistics, and in these options, hit standard deviation, variance, and range. Hit continue. If you want to run it immediately, hit OK. If you want to save syntax to run it later, hit paste. So I'll go ahead and hit paste. Some of you have been asking me about this. So you could go to File, Save As, and save this syntax for use later. So if you wanted to return to this without going through all of the steps, you could have that for yourself if you want. All you would have to do is highlight and hit run. And now a few of you asked, why did I add a comment? Well, I add comments so that I can remember what I do later. So this is to check calculations on variance lecture. So that way I can remember, here's what this group of stuff is going to do for me when I highlight it and hit run. That's all a comment is. It's just a reminder to yourself for later. So let's hit run on this. And we can see right here the number of people in our data set is 10. That matches over here. 10, our standard deviation. So in SPSS, these will always be samples. They assume you have a sample. So actually, let's start with a range of 7. So that is exactly what we calculated here with our range of 7. Let's pull that output back up. Standard deviation, let's go there in a second. Our variance, 5.778. So sample variance, 5.778. So it's the same exact thing. And then looking at our sample standard deviation, 2.4037. So you can see right here, 2.4037. They do match up. So SPSS and what we've done here in Excel, we're doing the exact same thing, but I'm trying to give you a glimpse into kind of the background of it. In your homework, I ask you to calculate some of the variance, some of the standard deviation kind of things. You can do it by hand, just write stuff out this way. You can do it in Excel this way that I've set up the table. You can calculate it the more kind of high school algebra class way that Sal Khan did in that video. Whatever works for you, calculate it your way. Personally, I think this is easiest, leads to the fewest errors. Whatever method you choose, please be sure to show your work and turn that work in for me. If you have any questions, let me know in the comments.